I do this, which is another way to do it, just as a demo. Oh, I gotta get further away. There, right? There's the shadows. And so you already made, right? You already decided light traveled in straight lines. And where I see this pink is called magenta, what light is being blocked?
Yellow.
Green. What is it? I only have red, green, and blue.
Green.
Right? So light travels in straight lines, and so the light that gets blocked here is green. That means that red and blue make this color, which we call magenta. And then over here, I don't know if I have mine the same as on the paper. So this one, light travels in a straight line. I have red on the far right over there. And so the red is getting blocked, correct? To here. So this is blue and green. And what about the yellow? What two colors? Yeah, blue is being blocked, right? And so it's red and green. Now this is called light addition. You're mixing colors of light. This is not subtraction like paints. And I'll talk about paints in a second. Your eye has only these three receptors. Your eye has rods that sense that sense light at all. But you only have three receptors, and one's for red, one's for green, and one's for blue. That's it. And the combination of light intensity and light frequency tell your brain that Roy G. Biv is there, right? But you have only cones, red, green, and blue, and that's it. So if I combine the red and the blue, you can see that my brain says, oh, there it is. And if I combine the green and the blue, then I get cyan. And if I combine the green and the red, I get yellow. And there you can see where all three are in the middle. That's white. So now so that's addition of light. It's different. It's energy that's hitting your eye. If I want to talk about color subtract,
yep. So that means that, back to Roy G. Biv, even minus indigo, that, because I tell my kids all of them together make white, so that means that orange then is really a little bit of red and a little yellow. Or
yeah, right. More red than green probably, yeah. Right? But, so it's not, so if you would look at this for a second. Emily, will you go by the lights? So here we'd say, oh, here's all the colors, right?
Yeah.
Now, the reason this is red is because the red light hits it and the red reflects to your eye. And what it does is it absorbs the green and the blue. So Emily, the red is on your right, the far right. Put your hand over the light and look at what color this turns, right? The only reason you see red is because you have red, green, and blue hitting the ring, and it subtracts, it absorbs the green and the blue. Now bring all three back again. Okay, now let's pay attention to, I don't know, this green up here, or these two greens, and the green is on your left. So she's going to cover up the green. Oh, that didn't change too much, did it? So that means this does not match that filter. So let's try my guy. I'm going to put my guy up here. And you can think about his shirt as being red paint. Somebody painted this red. And what red does is so it looks, red paint looks red because it reflects red. That's the energy that can get to your eye. So one more time, cover up the red. Look at his shirt. Okay, now uncover it. Now look at this green sheet of paper. And now cover up the green. And look at that, right? So if there's no green energy, green is energy, it's a certain frequency. To be reflected, you can't see it. The reason this is green is because it absorbs the blue and the red. And here's the blue, and then she'll cover up the middle one, right? So this is subtraction. This is color because it's light subtraction, and what you were just dealing with was light addition. Different colors, just like pitch, is how our human brain interprets the frequency of sound. Color is how our human brain interprets the frequency of light. Got it? Different light for different frequencies. So all you need are red, green, and blue to make white. Okay? Now, it's still sunny outside, so I want to show you one more thing. What was black? When you had a black shadow, what was that? No light, right? Nothing was getting to your eye, and so your rods that Kelly was talking about that sense any electromagnetic energy, they're saying none there. But what's white? Red, green, and blue. So white reflects all those wavelengths, all those frequencies, and black has absorbed any frequencies that are there, and in your case they were black. So a black shirt absorbs all that energy. Where does it go? Heat. So is it true, is it warmer to wear a black shirt than a white shirt? Yeah. So we're going to go outside for a second. Does anybody have anything black on that I do?
I got a black sweater on.
What can I set on fire?
Oh, to set on fire.